All right, here we go. So now what we're going to do is we're going to start talking about systems of linear equations, and we're going to start with the system of equations where we have two equations with two unknowns. We call this systems of linear equations in two variables. Okay, so we're going to start with the idea of how do we know we have a solution to a system of linear equations in two variables. Well, we're going to start by basically using the fact that when we talk about one equation, right, we talk about the equation of a line, right, a linear equation, and we know that we have a solution to that equation if we plug in a point and we get a true statement, right? And so we know that that is a solution. That point is a solution to that equation, or in other words, graphically speaking, the point is on the graph of that line. So if we extend that to multiple or systems of equations, for example, what if we want the solutions of two equations? Okay, what if we have two equations, two linear equations, and we want to know, hey, is this point a solution to the system? What we would need to do is we would need to show that the point is a solution to both equations. So basically you would plug it into both equations and you would have to get a true statement for both equations. Okay, so that means that point would lie on both graphs, right? The graphs of both equations, and the only way that happens is if those graphs intersect. And so that'll give you an idea of where we're going and one of the things we look for. So anyway, let's dive right in and let's look at an example. So in this example, we have this system of two equations and they're in standard form. Okay, so we have 6x plus y equals -2. 4x minus 3y is equal to 17. And for part A, we're given the point 1/2 comma -5. So now, they want us to show or to see if these are solutions, if this point is a solution to this system. So what we're going to do is we're going to plug this point into both equations and see if we get a true statement. So let's plug in 1/2, right? So here we'll plug in 6 times 1/2 plus -5, is equal to -2. Okay, so if I do that, then I get 3 plus -5 is equal to -2. And here I get -2 is equal to -2. And sure enough, that's a true statement. So it worked for that one, but we're not done. We got to now show or see if it works for the other one. So now we're going to plug it into here. So again, I'm going to do 4 times 1/2 minus 3 times -5 is equal to 17. And so this is going to give me 2. This is going to give me plus 15. Which is equal to 17, and then of course I get 17 equals 17, which is true. So therefore, this point is a solution to the system of these two equations. Now, let's do part B now. So part B, we have 0, -2 that we want to test. Okay, so again, we're going to plug it into the first one. So that's going to give us 6 times 0 plus -2 is equal to -2. And of course, this gives us 0 plus -2 is equal to -2, which gives us obviously -2 is equal to -2. And we're good. Boom. All right. Now let's do the other one. Okay. So now we're going to do 4 times 0 minus 3 times -2 equal to 17. This is going to give us 0 minus, plus 6 is equal to 17. Obviously, 6 is not equal to 17. That is a false statement. And so therefore, 0, negative 2 is not a solution to the system. And that's it. That's how you do it. Have a great day.